Hi guys, so let's solve this one. This is joint probability, and the first thing you usually are told is that the probability is from 0 to 1, so it makes sense. And the second thing that they are going to probably ask you is to find what values, like from the range from these values from to this guy. And the way for you to solve this, if you add all these up, let's say alphas, all these alphas plus this one, you're going to get 1. And this is not going to help you because this is 3 alpha minus 3 alpha, so it's equal 1. And if you make them all 0, that doesn't help you as well. So the way for you to solve this is taking this first element that you have an expression and you do it as follows. So that is equal to 0. So you get this guy to this part. So you have 1 equals to 3 alpha, and this gets the alpha alone here, so you have 1/3. So what this means is that this guy range is between the values of 1 and 1/3. This is how you solve this problem. So in this next problem, you already told what's the value of alpha, and they are telling you it's 1/6. So you start off with this table, and we're going to substitute the values inside. So the first one, I'm going to just change those inside here. So 3 times 1/6 is 3/6, and 6/6, which is 1, minus 3/6 is 3/6. And the remaining ones is 1/6, 1/6, 1/6. So let's just change that directly here. And we are asked to find the expected value of u and the expected value of v. How are you going to do that? We are given two expressions, this one and this one. So the first step to do is a chart like this, a table like this. So you have x, y, you have u and v. So 0, 0, 0, 1, 1, 1, 0, 1. And all you're doing here when you're doing these problems is putting these values, not these ones, just these ones, and plugging these in these expressions. So u, when both are 0, 0 divided by 2 is 0. Then you have 1. Remember that this is a module. I just forgot to put it here. So 0 minus 1 then becomes positive. So this is 1/2. This one is the same thing, and 1 minus 1 is 0. And for the other ones, you have v, so x plus y, so 0 plus 0, then minus 0, that's just 0. But then this one, you have 0 plus 1y from this part, minus 1 times 0 is 0, so this is 1/3. And this one is the same thing, so 1/3, and this one is 2. So 1 plus 1 is 2, minus 1 times the other one, so 2 minus 1 is 1/3. Notice that this equals 1 and this also equals 1. So you have this intermediate table, and this is needed in order for us to compute the final table. Let me show you. So now we know that u varies between 0 and 1/2, and v varies between 0 and 1/3. So the same thing that we have in these tables, we're going to do the same thing for u and v. So u varies between 0 and 1/2, and same thing for v, it varies between 0 and 1/3. And all we need to do now is figure out what are these values. So let's just do that. The rule for that is as follows. So the question that you need to ask in order to get this right: what are the values that u and v are 0? So you're going to go back to this table and you find an entry here. So this is true. You have a situation where u is 0 and v is 0. So you have the entries from x and y that are 0 and 0. So you're not going to get the entries here and 0, 0, so it's 3/6. So this is the first entry. The second entry that you have is, what is the situation that you have that u is 0 and v is 1/3? So you have a situation here in this board where u is 0 and v is 1/3. And you're going to check those values in x and y. It's the entry where x is 1 and y is 1, so which is this one. So this is 1/6. And the other entry, what is the entry where u is 1/2 and v is 1/3. So what's the situation where you have this situation that's 1/2 and 1/3? And notice that we have two situations here. In this table, we have the situation where you have 0 and 1. So it's 0x v1, which is 1/6. But you have another one where x is 1, so it's this one, and y is 1 as well, so 1/6 as well. So you have 1 plus 1/6 as well. And in this one, what is the situation where u is 1/2, but v is 0? And if you notice this table, we don't have any. So this is 0. No situations here. Now, in order to calculate the expected values, you always find the marginal distributions. So we have here u, we have here v. So this is the marginal from u, and this is the marginal from v. So in order to get the expected value, just sum these up first. So this is 3/6, and this is 1/6 plus 3/6, so 6/6 makes sense because it's always equals to 1. And this one is 4/6. This one is 2/6, so all also equals to 1. So this is right. So in order to find the expected value of u, since we now have the marginal distribution, you just use the entries. So you have 1. This is first one is 0, so it's 0 times 4/6 plus the other entry 1/2 times 2/6. So this is equal to 212, which is the same thing as 1/6. And for the other one, this is the same thing, but now we are using the v1. So v comes from the bottom. So expected value of v is 0 times 3/6 plus 1/3 times 3/6, which is the same as 1/2. So this is also equals to 1/6. Sometimes in these problems you will find that they'll ask you if u and v are independent, and the way for you to answer these is in this following format. All these entries, this entry must be the product of the marginals from this entry and this one. So if this one of these fail, but all of these must equal. So if any of these fail, u and v are not independent. And you can look at this exactly from this one. This one is 0, and obviously 0 is different from 3/6 times 2/6. So these are not independent.